Okay, another test here. This time, you see how I have the magnets inside this rotor now. They're like this. This is smaller than what's in there. This is 1/2 inch wide, 1 inch wide this way. Grade 52 neodymium disc magnet. So I'm just using this as an example. So they're like this now. Last test I had them like this. Now they're going to be like this. Okay? And it's going north, south, north, south. Okay. Some things I made improvements is I put in some new inserts. I put a new insert down there and another new one here. And the bearings fit nice and snug here now. So let's just do a quick, here's what I'm going to use is the pony motor. And this is going to be going at 1750 RPM, and that'll make this one go at 1750 RPM, which is the sine wave latch speed for a 4-pole AC motor. And I'm going to connect the shafts with some tape. And let's just run this really quick and see what it draws. I'm in 20 amp setting. It should read 20 milliamps. Have a 4 UF run cap. 4 UF run cap. And there we go. Yep, 20 milliamps. This is in 20 amp setting. I could put it down more accurate at 600 milliamps, but I don't want to do that. Just leave it here. Less chance of blowing a fuse. Okay, I just wanted to show how the pony motor, also the prime mover, is working. Now I'm going to put this together and put this on and tape it to that shaft, and we'll see how much power it makes. Volts and amps. Amps will just be a crowbar with an ammeter, just short it out with an ammeter. Volts will be maximum volts. And then I'll do the same test as I did on the others, where I'm going to short out one of the 3 phases coming out of this motor. It's connected in Y, WYE. So there's like one phase here, one phase here, and then one phase here. So I'm just going to do a quick test, see how much it goes up in draw when I short out one of these phases. Okay, so hold on, I'll put you on pause. Okay, it's together now. Here's how it spins. Not so as good as this, but it's okay. So now, and there's very little fore and aft play. Very little fore and aft play. So now I'm going to tape it to it. Okay, got it going. There's one little incident, but It's going smooth now. I'm running on a 4 UF run cap still. There's enough power to spin this at 1750. I put this box here just in case something wants to fly through the window. And let's see what it draws right now. Remember, it was by itself, it was 20 milliamps. And while it's spinning this, it's 50 milliamps. So, it takes 30 milliamps and 120 volts to spin this, no load. Okay, now comes the test I want to do. Short out one of these. It wants to stall. One moment, I have to make a larger UF run cap so it won't stall. One moment. Okay, what I've done is added 2 UF to 4, so now it's a 6 UF run cap. And notice the draw has gone up to 160 milliamps now. And I should be able to short this out now. When I short it out, it keeps going, but it's definitely lugging. Okay. So, what's all this mean? Let's see what the voltage is across one of these and what the amps is when you short it out. And we'll run an ammeter like right across here. Just, I call it crowbarring. You just short it out with an ammeter in 20 amps AC. See what we get. Okay, one moment. Okay, let's do I'm going to take this ammeter, put it right across here. There's no resistive load. We're just looking at when you short out a phase. 1, 2, 3, go. Short it out. We got a lot of amps. Ah, it's stalling. Started to stall. Let's do that again. About 130 milliamps. If I let it go, it'll start to stall. Now let's see what the voltage is. Voltage across just one phase is 46.4 AC. Okay. So I'm not so impressed with this because there's a lot of lens braking going on. So there's another test. Right now I think only 2 magnets in the rotor would be better for what I'm doing now. I'm going to do one more test. I'm going to see if I can get this to run on AC. Get this motor, I'll hook this up to the same power going in. Let's see what happens. And I'll have a 35 UF run cap over here. Okay, one moment. Okay, now when I connect this green wire to here, it's going to be having power going into this motor and this motor at the same time from a common source. 35 UF run cap here, 6 UF run cap here. There we go. Wow. Going now. Now I'm going to see what the power draw is from the grid. One moment. Okay, had a few problems, blew a fuse. But it's running now. I'm measuring the input directly from here. 240 milliamps. It's spinning this. Interesting, when I hook the 35 UF run cap up to this motor between L2 and L3, the draw goes to 240, but if I take this off, no run cap here, 160 milliamps draw from the grid. So this makes the input power go up. I don't have here we go. I don't have the both motors sucking in power, but I will do that right now. There we go. Now we have a draw of 148 milliamps. Let's take this off. See, it needs, when it's drawing power, and this is drawing power, as it is now, you want the run cap. Because without the run cap, it's 2.1 amps coming from the grid to both motors. You install the run cap, 1.46. I wonder if I can go back to a 4 UF over here. You want a 6 over here. 6 UF on this, run cap on this, 35 UF on this. And the draw is 1.46. Okay. Now, let's see something. This is going to be my final test for the evening, or something gets destroyed. I'm going to unhook the power to this motor. So it's only drawing, only this motor will be sucking in power. So this is answering the question, will this run off AC? The rotor magnet configuration I have now with the edges going past the laminate. You know what is good is I don't feel any heat. So far, I don't feel any heat coming out of here. And I have both motors are drawing from the same source of power, 60 hertz, 120 volts. So actually that's kind of good. because in all my other tests I was getting a heat buildup. Okay, so let's see what happens. I'm going to disconnect this. Well, so much for that. It doesn't run on AC. Okay. I did get it to run on AC when I had only 2 magnets in the rotor. So, I guess that's about it. Thanks for watching.